Welcome to the presentation of fair and accurate age prediction using distribution-aware data curation and augmentation, a paper done in collaboration between NTU and Ben-Gurion University of the Negev in Israel. Our motivation is that people of different ethnicity and gender are predicted systematically unequal by facial recognition systems. This has been shown by Amazon, by Microsoft, by IBM, and led these companies to pull out their facial recognition systems either completely or with restricted use without law enforcement agencies. Therefore, we propose to provide a fair and accurate approach to enable equal prediction of age. To do so, we present two things which we suggest integrating into the development pipeline of these responsible AI systems. The first one is distribution-aware data curation. Here, we have heavy emphasis on the need for balanced creation of test data to identify which sensitive features play a role and then select the data accordingly, balancing it among gender, ethnicity, and age in an equal fashion. This effort alone already shows that we can improve the fairness, which we measure by taking the average to the actual age for each of the different sensitive features, by up to 32%. In addition, we acknowledge that we can't always get the perfect data that perfectly balances between the different features. Sometimes we need to fill the gaps, and therefore mutation is a common way to do so. However, how should we actually mutate the data? Can we use mutation techniques to fill the gaps in a way where we can expose the model to new behaviors, to new inputs that help the model to understand the application diversity it will be exposed to later on? Therefore, we integrated out of the distribution technique to filter out the augmented data that is either too common, meaning it is redundant information or may produce overfitting, or too different, where people look like zombies, as we can see in the middle demonstration. And therefore, we focus on the data in between, the one that is challenging for the model, new, and helps the model to generalize to so far unforeseen data. Looking at our results, we have achieved incredible results. First, we conduct a series of experiments. The first one is where we look at the differences of our method outperforming between other ways of curating the dataset. So only looking at the distribution-aware data. Here we can see that if you just would collect it randomly, it's already a little better, from 5 to 4.03. But if you specifically try to focus on the sensitive features, you can reduce the mean absolute error to 4 and raise the fairness from initially 23 or 61 for ethnicity and gender respectively to 67 and 81 respectively. Fairness score again being here the ratio of how many ages are close to the actual age for each of the sensitive features. Moving on to the mutation, we looked at different areas of where we can mutate. Too different is 0 area, too similar is 1 area, and we identified the optimal setting where we cut off the too different area only, showing highest performance on generalizability and fairness. Finally, we compared our method to Microsoft and Amazon and outperformed both, not only in performance, but significantly in fairness, showing as a conclusion that integrating distribution-aware data curation and distribution-aware data augmentation makes a significant difference. Thank you very much for your time. Have a great day.